Hello, and welcome to Future Now, the podcast where we ask questions today about technologies coming tomorrow. So, have you ever had a really cool idea for a tool or maybe a toy, but don't have any way to create it? Maybe you draw it out or create some sort of blueprint, but don't really have a way to realize your creation. Well, why don't you print it? Now, 3D printing has been around for some time, but the promise of it still has yet to be fully realized. So I am talking with Dhruv Bhate, who researches 3D printing here at ASU and also teaches courses about it at the Polytechnic campus. So let's check it out.
My name is Dhruv Bhate. I'm an associate professor at the Polytechnic School, which is one of the 6 engineering schools that we have at Fulton. My research at ASU really focuses on 2 pillars. One is really interested in looking at metal 3D printing and the properties, the behavior of metal 3D printed parts. And the second one is really to unlock design and specifically think about opportunities in design for 3D printing. In the past, our manufacturing processes have constrained the kinds of designs we can realize. And now 3D printing has unlocked many of them. So now a designer can, in principle, really not be constrained by what he or she can design and can manufacture, but only be constrained by imagination. So one aspect within design that we're very excited about is things like honeycombs and lattices, things that actually, funnily enough, don't involve designing with material, but really thinking about how you can exploit empty space. Like a honeycomb, a bee's honeycomb has a lot of empty space in it. So those are the 2 broad things that we do in our group. And in addition to that, I teach courses in additive manufacturing, which is the formal name for 3D printing.
For anybody here at the ASU campus who might be curious or want to get involved, you operate through 3DX, right?
That's right. I've called my research group, 3DX Research. But I'm one of, I would say, 4 or 5 professors on this campus that do some work in additive manufacturing. I happen to be one of the, maybe I'm unique in the sense that everything I do is exclusively involves 3D printing, but there are many professors that use the technology in their research. And the group that we have is, that I've formed with my PhD students, my master's students, and my undergrads, is what we call 3DX Research. And we came up with that name because it really, it has 2 connotations. One is 3D, the implication of space, and the other part is the X. What do you want to put in that space? What material do you want to put? Where do you not want to put it? And how might we combine material, which is the X, and space, which is the 3D, to really construct parts, the sort that we have not yet seen. The aerospace industry, for example, is already very concerned with weight. And one of the exciting things about 3D printing, and one of the reasons they have been one of the early adopters of the technology, is because it allows us to take the designs that we used to have and make them even lighter. In some cases, even add additional functionality such that what used to be 2 parts can now become 1. So in that sense, 3D printing is unlocking the, completely shifting the paradigm. We're not thinking about, can I machine out a little more material in one more corner? It's about saying that part used to be just a heat exchanger. Can I now also make it load bearing? So I can get rid of some of these brackets that I used to have. So that is the beauty of, or the possibility and the promise of the technology. And that's really why we've called it 3DX, is to encapsulate that promise.
Perfect. So the idea is the X is a variable. It stands for whatever you want to come up with almost.
Exactly, yeah.
And so how broad are the applications of 3D printing? Like, where can it be used in different aspects of life?
I mean, this is one of the most exciting things of 3D printing, that it is so broad. And, in many ways, and I've thought about this, why is it so broadly applicable? And I'm not answering you, but the point is, if you look across multiple sectors, the aerospace industry, the biomedical industry, the automotive industry, any kind of engineering industry that deals with hardware, at some point uses 3D printing. But if you ask why is it, if you think about it, the reason 3D printing is so broadly applicable, from making aerospace components to making fabricating ears with collagen and things that you can actually potentially at some point implant into a human body, is because it's very simple at its core. And the idea is, if you've seen a funnel cake being made at a state fair, you've got this funnel and you're extruding some material out of it and onto a hot pan, and you're building this really complex funnel cake, which you would be hard pressed to make any other way and get a design that was so complex. But the idea at the core of it is to instead of starting off with big pieces of metal or plastic and then framing or fabricating what you want, you're actually dictating at every single point what material you want and where you want to deposit it. So this gives you an unprecedented level of control in a system that is fundamentally very simple. And that's why it's been able to penetrate across multiple domains. And the biggest adopters of 3D printing today, if you look at if you look at the revenue that they generate, are the aerospace and the biomedical industry. The aerospace industry uses them across the board, uses 3D printing technologies, but primarily today a lot of it is plastics, composites, and metal. The biomedical industry is primarily using metals for implants for bone replacement, like hip joints, for example, are gaining more popularity. In fact, there was the 10,000th hip implant was just fabricated a few months ago. So they've reached that milestone. GE with their LEAP engine that's on many Boeing aircraft now uses a fuel nozzle that is also 3D printed, and that fuel nozzle is a metal part, and they just certified their 30,000th fuel nozzle.
And when we're looking at these applications, and we can speak broadly here because I know you can go into so many specific examples, why are people switching to 3D printing? What are some of the basic advantages compared to the more traditional ways of producing?
It falls into three categories as I see it, okay? And the first of these, and the one that we are most interested in at ASU, but also other folks are also very passionate about it, is just the nature of the kinds of things you can make with 3D printing you just could not make with, say, in casting or forging or other technologies in the metal domain. But this is applicable even in the polymer domain or the plastics. What do I mean by that? Traditionally, when we make parts, we start off with material and we remove what we don't want. It's almost Zen-like in that sense. In 3D printing, we only put the material where it is needed. And that allows us to design structures and parts that have very complex geometries. And the minute you can start to do that, if you think of an insect nest, or if you think of a lot of biological structures like bone, they are not just doing one function, they're doing multiple functions. And the reason they can do that is because they can exploit design at very small scales. When we think of design, we are often thinking of the component at the largest scale that we visualize. This could be a handlebar on a bicycle. And you have these cables that run along the bicycle, and they're a separate component. You have a little bell maybe that's on the bicycle handle bar. And if you were able to control things down to a very fine level like you can in 3D printing, they can all be one thing. The handlebar, the bell, the cables can be integrated into the handle. In fact, some of the recent designs, this is not just a what if example. This is a real example because the last few Tour de France winners, especially when they do their time trials, are using 3D printed handlebars for that reason, because you can get down to the level of design where you can truly integrate different functions. And another thing you can do is you can customize it. So a reason why 3D printed parts are so popular in implants, for example, is because now I can give you an implant that was designed just for you. And as opposed to, prior to 3D printing, buying an implant was like buying shoes. You would buy a shoe in a particular size, and sure, it's okay, but you can do a lot better if you, for example, have an understanding of your specific pressure points your walking style, your gait, um, and feed that all into a simulation that will then design a better sole for you. And that's exactly what Adidas is doing. They do sell a 3D printed sole that is custom to the individual. And you have to go get yourself measured. It's not widely available yet, but that is one of the directions we're going in. So the first big reason why 3D printing is making such a big impact is because you can exploit design to a much finer level than you could with other manufacturing technologies. The second reason is really one of, to simplify, is one of convenience. And for example, the U.S. Air Force, right, has aircraft that go back 50, 60 years, and they're still in service. In fact, the Department of Defense spends something on the order of 60 to 70 billion dollars a year maintaining our fleet of hardware, and software. But a big component of that is replacing parts on aircraft. Today, you have to have a complex supply chain, right? You need to know where that part is coming from. It has to be available at the exact time that it is needed, or you have to store this large inventory of parts. Oftentimes, these supply chains are complex. They are international. This part is coming from another country. It may not be always available when you need it, so you need to have a second supplier. And these suppliers don't want your business because you are asking for 5 parts a year, right? And so the cost on these parts is enormous because you're only making 5 of them a year. And at the same time, you have to maintain this complex supply chain to make sure you have the part when it's needed. In comes 3D printing. You say, no, I'm gonna put that 3D printer in my depot that services that aircraft, right? And I'm going to say, guys, next time you need a part, don't order it, print it, and of course, we'll go through some qualification on that part, make sure the part can be produced to the requirements, and we can put it on our aircraft. So 3D printing, if you look at the folks that, look at supply chain management, from the business side, they see this as a big disruptor to suddenly say manufacturing does not have to be this complex outsourcing of multiple parts that are assembled, where inventories are managed. There's been this dream, in manufacturing to try and get to just-in-time manufacturing, manufacturing at the source, and that's the second big reason why 3D printing is making an impact, and many people are excited, especially those that work with low-volume parts and have very critical needs to make sure that they are available and in demand. The third reason why I think 3D printing is so exciting is because of our ability to combine materials. If you think about, a traditional designer, maybe I want to make a bumper for a car, right? And I have a list of materials I can choose from. There are a bunch of different plastics. Some of them may have chopped carbon fiber. And I say, okay, I'm going to pick this particular one. I know it can be manufactured in the shape of a bumper. It can go through the manufacturing process. The material cost is affordable. It has the required reliability, etc. And you then choose that material, you design to it, you do some analysis to make sure it can take the loads that you want it to take, vibration of the car as it goes through potholes, etc. And then you go to your manufacturing provider and you say, make me this bumper with this particular material. With 3D printing, what we can do and have more of the, and people are doing more of, is to combine materials in different ways. So I can say, the place where the bumper attaches to the car, I need that to be very stiff and strong. Can I get, a high carbon fiber, continuous carbon fiber composite at that point? But everything else, I want it to absorb energy. Can I maybe have less carbon fiber there and blend into a polymer structure that is cellular? Maybe it has a lot of empty space to absorb that shock. And that is something that would require you to say, okay, if you want this level of complexity, I have to break up this bumper into 3 or 4 parts, right? And supplier A is going to make one, supplier B is going to make the other, and then they're going to assemble them all, introducing labor costs and introducing interfaces between, mating surfaces and fasteners, and you get your nuts and your bolts and your washers, you add weight, you create places where you can have failure and cracks initiate. On a 3D printer, especially the direction folks are moving in, you can combine these materials together. We're not there yet compared to just pure play metal and polymers, but that's the direction and the opportunity that people see. Again, why is this possible? Because you're able to control at a much finer level. In there's one term that I want to introduce here, and that is just the way we are familiar with pixels, right, on a screen, and we think of two-dimensional space to be broken up or discretized is the fancy word into two-dimensional pixels. In three-dimensional space, we call it a voxel, and that is a volumetric pixel in a sense. So voxel, VOXEL, and that is the power of 3D printing. I can now modulate, material allocation on the level of an individual voxel. Just like if you have a two-dimensional screen, and you can now choose what you want a particular pixel to contain, as opposed to maybe the largest level of discretization is you hold up a white piece of paper, or it can be red, or it can be blue. But now I'm saying, no, you can combine these colors to make an image on a paper. I'm giving you, you have the freedom to assign voxels. So that kind of freedom is now available to us in 3 dimensions. So that's how I like to think about it. Those are the three broad benefits that I see. There are some niche areas, if you go to biofabrication, for example, it was in it combines all these ideas in one. A lot of people are working on transplant, and replacing the need for having a bank of transplant organs, available. Something on the order of tens of thousands of Americans alone, are unable to get a transplant in time and die as a result of that. So one of the opportunities is to develop biofabrication techniques. And again, here you want to combine different biological entities and still create a construct or a part, quote unquote part for a human that is custom to them, right? And in this case, not just custom from a design standpoint, but will their body be accepting of this new organ, etc. So when you want that level of control, everybody is for the most part going with 3D printing. To me, it is those three things.
And earlier we were talking about the applications of 3D printing, and where exactly does it stop? I mean, is there a theoretical point where you cannot 3D print certain items? And I ask that because, we're seeing people talking about 3D printing food, organs, like you said, and that's, you hear that and that sounds like some crazy future stuff, but it's not really, is it? The question basically is as this technology progresses, will we be able to 3D print anything we want?
That is a very good question. And it is hard to argue in principle that there are any limits to this.
Because the technology is so simple, like you said, right?
Correct. Because fundamentally it is allocating a material at a particular point. Are you limited today? Of course, you're limited by how small that point can be. What materials you can actually get to flow, depending on what process you're working with. The kinds of properties that part will have, and you're also heavily limited by cost. Even if you can do it, you may not want to, because there are better ways, cheaper ways to do it. But if we zoom out of the practicalities, and if we just ask ourselves this question in principle, can anything be 3D printed in principle, given enough time and technology development, and really ultimately human imagination? I lean, and this is a controversial point, I lean on the side of yes, it can. But you will find others that will find that they won't quite agree with me, and they will point to fundamental limits of manufacturing and discretizing material. Another way to answer that question is to say, where is this technology going, and what are some of the, if I was to leave and go to an alien planet and come back 10 years from now, what will 3D printing look like? A lot of people, me included, believe that it really rests on the materials. It is the development of new materials. Why are we constrained a lot of times with 3D printing? Why do people feel like everything cannot be 3D printed today? A lot of times it is because the materials in question that we are using to create our parts with these 3D printers were not really developed for them. We are, let me give you an example. In steels, what kinds of steels can we 3D print today? We can print a steel called 316L. We can print another steel called 174PH. And these are steels that have been around way before 3D printing came along. And what folks said is, I have this 3D printer. Let me take that metal that everybody in the market wants and is buying, and let me see if I can 3D print with it. That was metal 3D printing 1.0. Metal 3D printing 2.0 is, I wonder if I can design an alloy from scratch that will work just beautifully with this process. And I'm using metal as an example, but this applies in plastics, this applies in ceramics, in composites, even in biologicals, or printing biological materials like collagen, or a lot of, a range of different biological materials that people are extruding and printing today. So to me, that is why we have not unlocked the complete potential. So when people cite a limitation, oftentimes you trace it back to an opportunity where if you redesign this material from the ground up for the process, a lot of those limitations would get ABS, right? The most popular plastic that is 3D printed is what Lego has been using since 1934 or 1940. And so it's that common of a polymer. We can do better, and we are. And people are researching not just optimizing a material for a particular process, but can I work with recycled plastics? Can I work with sustainable materials? That's also coming into play here. So I think the best is yet to be, and I think the answer to that, from my perspective, my opinion, is that in principle, at some point, yes, anything will be printable. You may not want to do it for other reasons, but can you realize a three-dimensional object that you can conceive of? Yes.
So that's all I have for in terms of questions and everything. But of course, I like to throw out, is there anything else you think people should know about 3D printing, the space, the future of it, or anything like that?
I'll reflect on a couple of things that I pick up from interactions with my students. I find that there are some students that are excited about 3D printing in its own right, and there are some that see it as being something that they could potentially apply in whatever jobs they take on after graduation. And both are true. If you're working in engineering and you're working with hardware and you're making parts, it's very likely you will need to use 3D printing at some point. So first, one of the things I like to tell all my students is that manufacturing has increasingly gotten distant from us. As it's moved offshore, as it's localized. Even within the U.S., there are certain regions where a certain kind of manufacturing is done, and we have lost the connection with how our products are made. Most of us do not know how the things around us are really made, and 3D printing allows us to get closer to that because of its relatively low cost entry point. For you can buy a 3D printer for a few $100s, and what I've seen happen is eventually when you do get that 3D printer in, you start to ask questions about other manufacturing processes, either in terms of saying, well, if I could print that, should I? Can I replace that other part? And you start to wonder, why is the other part made a certain way? So my pitch for 3D printing is it's a gateway into manufacturing. It's a window into manufacturing. And I've seen that happen with many of my students. A second academic point that I want to make is that 3D printing represents this beautiful coming together of several different disciplines in the engineering sciences, right? Mechanical engineering in the sense of design, right? You want to design a part that's going to survive and perform. You have manufacturing itself, which there's lots of physics and chemistry, polymer chemistry, and how these parts are made. So it brings together a lot of material science. And then there's manufacturing. How do you set the right temperatures on your machines, the right powers, the right speeds at which it dispenses material? Those are all different concepts in manufacturing that you need to master no matter what you're doing, whether you're making a 3D printed plastic part or whether you're making a silicon semiconductor wafer. for a chip to go into a laptop. So those principles are very similar. You conduct experiments, you evaluate your outputs, and you decide what is the optimum. And so 3D printing in this very accessible way brings together all these different ideas. So if you are a generalist, if you are passionate about work that's at the intersection of disciplines, I find it hard to find any other field that represents those. And I'm biased because I do this every day, but everything has to come together to realize that component. So I find it very exciting for that reason. If you want to commit to computational mechanics, and of course that's one single domain, great. But if you want to get a flavor of different aspects of engineering, it's hard to find one central platform under $1,000 that allows you to do these explorations on your own. At the Polytechnic campus, we love to say and we love to emphasize our hands-on aspect of our learning process. And I've found it, found 3D printing to just be an amazing representation of that ideal.
What do you think? Could and should we 3D print anything? Well, if you want to get your hands on some of this tech, there are 3D printers at both the Tempe and Polytechnic campuses, and you can take classes on the subject at the Polytechnic campus. It's a simple technology that can help you make whatever's in your mind's eye. For the State Press, I am Balin Overstoles McNair.